Welcome to the GMAT Strategy Podcast. You're here because you believe there's a better way to study for the GMAT, and so do I. I created the GMAT strategy to maximize your results and minimize your efforts so you can get to the fun parts about business school and life as quickly as possible. My name is Isaac Puglia, and I've been teaching GMAT classes and tutoring privately for the GMAT for over 6 years, and I personally have achieved a 99th percentile score on an official GMAT exam and helped hundreds of students get into the business schools of their choice. I'm excited to be a part of your MBA journey since I think the world can benefit from the best possible business leaders that we can find. And if this show is bringing you value, please share it with your friends and family who are studying for the GMAT so that together we can make this process as easy and painless for as many people as we possibly can. Let's go. Today, I want to talk about how to plug in numbers on problem-solving questions that have variables in the answer choices. This is a really valuable and important strategy that I think is extremely underutilized amongst students, and I see people making a lot of simple mistakes that, if they corrected, would make life much easier for them. So first, let's make an important point here, which is I'm not talking about data sufficiency questions with this strategy. There are definitely many times to plug in numbers on data sufficiency questions and test different situations with those numbers. That is a subject for either a different podcast or a future lesson. Today, we're not talking about data sufficiency questions at all. We're only talking about problem-solving questions that have variables in the answer choices. Now, when you see a question that has variables in the answer choices, a problem-solving question that has variables in the answer choices, most people's first instinct is to use algebra to solve those questions. If it's a word problem, they want to set up some equations. If it's an algebra question, they want to do a bunch of algebraic manipulations to see if they can get the right answer. And many times, that is the optimal strategy. But if that's the only strategy that you can employ on those questions, you are a very one-dimensional test taker. And it's going to be relatively easy for the GMAT to serve you up a harder question that might either take a lot of time off the clock or that you might not actually be able to get right using algebra. So if you think about a similar situation, that's sort of like being a basketball player who can only handle the ball with your right hand. If I'm defending you, I pretty much know what you're going to do every single time you're handling the ball. And you're going to be very easy to shut down, very easy to defend. And you don't want the test to be able to block you when you're taking the exam. So if they show you a hard algebra problem with variables in the answer choices, and you're starting to set up the algebra and you think this is too complicated, this is annoying, I might not be able to get this, or this is going to be very error prone because there's a lot of negative signs I have to distribute, things like that. If you don't have an alternative, then you're stuck doing that very risky approach. So today's lesson is all about giving you that alternative so you can be a multi-dimensional player on the GMAT. So even though I've said this a couple times, it's worth reiterating that the only time you can use this strategy, or really the signal for when you can use this strategy, is if a problem-solving question has variables in the answer options. If there aren't variables in the answer options, chances are this is not going to be a good strategy. But if those variables are there, it's almost certain that you can use this productively. So how do you actually do it? I'm going to go through a quick overview of the 3 steps, and then we're going to go through each step in detail, and we'll do a quick example, and I'll give you some tips. So step 1 is you replace the variable or variables with numbers. Second, you calculate an answer to the question. And third, you test each answer choice for a match. Let's go through these one at a time. So step 1, replace the variables with numbers. If there's only one variable in the question, then this step becomes relatively straightforward. However, if there are multiple variables in the question, then the best bet usually is to start by plugging in for the numbers that appear in the answer options themselves. So for example, if a problem has variables x, y, and z, but z is the only variable that appears in the answer options, it's almost certainly the best move to start by plugging in a number for z, and then either solve for x and y later or plug in numbers for x and y later. Now, it depends on the problem whether you'll end up having to solve for the other variables or just create numbers from scratch for those variables, and as you practice this more, you'll develop a pretty good judgment for when you should do which. Now, one quick tip there is if there is an equation presented in the problem, such as x plus y equals z times 7 over 4, then the numbers that you select, you're free to select basically whatever numbers you like as long as they fit that equation. You must select numbers that fit that equation. So in that situation, if z were in the answer choices but x and y were not, I would insert a number for z, and then I would plug that into the equation, solve for x and y, and then pick some numbers for x and y that fit whatever result I get. So that's the first tip. When you're plugging in and there's multiple variables, plug in for the numbers that appear, plug in numbers first for the variables that appear in the answer options, and then solve or plug in for the other numbers later. Next tip would be to make sure you are obsessive about writing out which variable is which number very, very clearly at the top of your scratch work. So if I'm plugging in 10 for z, I want to very clearly write z equals 10. And then later on, if I'm plugging in 3 for x, I want to very clearly write x equals 3. It's a very simple maneuver, but the biggest thing that I see people make mistakes with when using this process is not writing these things down clearly. And for whatever reason, that causes tons and tons of problems for them later on in the technique. So it's such a simple thing. Just start with good habits from the beginning. In terms of what numbers are good to use, I would recommend avoiding 0 and 1 when you're using this strategy because they're a little bit risky. They'll definitely make the math easier up front in the problem, but it makes it more likely that more than one answer option is going to match when you get to the last step, testing all 5 answer choices, and then you'll have to repeat the process. 1 and 0, if I had to estimate, are probably going to work maybe 3 out of 10 times, and those are kind of low odds for me. I think for me personally, I would prefer to select a different number and have the math be slightly less easy, but have it be basically guaranteed that I'm going to get the problem right with just one repetition of the strategy. So if you are a little less risk averse, then you can feel free to use 1 and 0. I'm just saying I don't use those very frequently, if at all. The best numbers, in my opinion, are numbers that are easy to work with, and sometimes that's contextual to the problem. If you're not sure, starting with numbers like 2 or 5 or 10 that are relatively simple and small can be a good place to begin. If you're doing a percent question, a number like 100 is generally a good number to use. If you're doing unit change questions, like converting between inches and feet, then using numbers like 12 and 24 is wise. If you're converting things like minutes to hours, then using 60 or 120 is a good idea. So the best numbers are going to be contextual to the problem, but there's also an important point to make, which is you won't always know what are the best numbers to pick, and that's okay. In that situation, you just want to pick something and make your move. More on that in a moment. So that's how you pick numbers wisely. Once you've selected those numbers and written them down clearly, now it's time to go to step 2. Step 2 is to plug the numbers into the question and solve for what's being asked. So let me give you an example. Let's say we have a question that says, Sarah is 12 years older than Ben. If Sarah is Y years old, how old is Ben in terms of Y? So this is probably a little too simple to be on a real GMAT, but you'll get the idea from this example. So Sarah is 12 years older than Ben. If Sarah is Y years old, how old is Ben in terms of Y? So quick tip, this phrase in terms of really messes with people a lot. And when you're when you're plugging in numbers using the strategy we're talking about today, you can safely ignore that phrase if you want to. And you can just say, okay, the question's asking me how old is Ben? And you can just forget about the in terms of Y piece. Technically, what the in terms of Y piece means is solve for Ben's age, but on one side of that equation, Y is the only variable. So technically what in terms of means is solve for Ben, but then when you have Ben equals blah and whatever you're writing down there, Y is the only variable on that side of the equation. Now, in this particular question, there's really only one variable, Y. And so we don't have to stress about that too much. But in other problems where there's multiple variables, like sometimes 3, 4, 5, 6 variables, then that's what the in terms of piece means. It's you're solving in terms of just that one variable. But again, because we're talking about plugging in numbers, we don't have to worry about that. In this situation, we don't have to worry about the other tips I gave earlier as well. The other tip about only plugging in for the variable that appears in the answers because there's only one variable in the question. So let's just plug in for Y and start our process. Our first instinct would be to make Y a relatively small number like 2. But you'll realize if you make Sarah 2 years old and she's supposed to be 12 years older than Ben, then Ben is going to have a negative age. Now, it's worth saying that we will still get the right answer if we execute the rest of the process with Ben being negative 10 years old in this case. But I wouldn't recommend doing that because it's going to be a little confusing for your mind. Your mind isn't used to thinking about people having negative ages, I think. And it's going to just make the problem a little bit easier to work with because you're going to be working only with positive integers instead of negative numbers, which add one element of risk to computing. So instead, I would say, well, if she's 12 years older, then let's make y equal to 15. And the other important point to make here is it's totally fine to pick a number that doesn't work if you're not sure what a good number is going to be, and then just change it later. That's really the beauty of plugging in numbers, is you can use whatever numbers you want. So I see a lot of people get paralyzed when they first learn this strategy and they start practicing on their own and they think, well, how do I know what the best number is? And you don't have to worry about that. Don't worry about picking the best number. You don't even have to worry about picking a good number at the beginning, because if your number isn't good, you can just change it. You can just change it later. No big deal. So let's say we plugged in 2, we think, oh, that's not going to work so well, so let's make y equal to 15. Now all we have to do is figure out what the question's asking us for and then solve for that. So this question is asking us, how old is Ben? So if Sarah is 15 and she's 12 years older than Ben, then we do 15 minus 12 and Ben is 3. That's the answer to the question. On the GMAT, it's likely that your calculations will be a little more involved than that, and that's fine. This is just a very, very simple example because I'm doing this only via audio, and most of the time that I would be teaching people how to do this, I would have visual aids, so I want to keep things as bare bones as possible so you can just understand the fundamentals of the technique, and then you can practice it on more intricate problems when you're ready. So if the problem is more complicated, we would just do a little bit more math. Our math would have a few more steps, but we would eventually arrive at a numerical answer for Ben's age. So that takes us to step 3, which is to test each answer choice for a match. And what we're looking for is an answer choice that when we plug in our number, we get the same answer that we just calculated in the problem. So let's say answer choice A says y plus 7. Well, we chose y as 15, so we would plug in 15 there, and then the question we'd be asking is, if we plug in 15 for y, will the result of this answer choice be 3? The answer that we got to the question in the previous step. Now, this step is kind of where the magic happens, which is kind of cool. And if you haven't seen this process work in the past, then it's kind of surprising, I think, the first few times that you use it. And it's kind of fun because you can take questions that are supposed to be really difficult and have a lot of algebraic steps in them and get them right without doing any algebra at all. You can basically turn them into arithmetic problems, which, like I said, it may not always be the optimal strategy, but I think it's a very, very good option to have. And for many of you, it will be the optimal strategy, and you will favor this over algebra frequently and significantly, and that's fine too. So basically what we're doing when we're testing the answers is plugging our variables in, plugging our numbers into the variables in the answers, and seeing if we can find a match to the answer we calculated in step 2. So obviously if A says y plus 7 and y is 15, then we do 15 plus 7, we get 22, and that is not equal to 3. So A would not be the answer to this question. Then we repeat that for B. Let's say answer choice B says y plus 8. Well, 15 plus 8 is not 3. And that's really all that I'm asking when I'm testing each answer choice, is I'm just asking, will this equal 3 if I plug in 15? Let's say C says y minus 8, 15 minus 8. That's a lot closer to 3 than the first two options, but still not there. Let's say answer option D says y minus 12. Well, 15 minus 12 is exactly 3, so we're happy, and we keep that. Now, many of you will be tempted to stop at this point and select D, and I strongly recommend not doing that. Always test all 5 answer choices, because it's still possible that one other answer choice could equal 3, in which case we would just repeat the process with a different number, and that wouldn't take us super long. And then that usually gets us clarity. Now, again, if you avoid 0 and 1, it's unlikely that more than one answer will work, but it is still technically possible. So let's say E, answer choice E says y minus 7. 15 minus 7 is not 3, so we're comfortably picking D at that point. And the time you save by not testing other answer options is rarely worth the risk, in my opinion. So again, if more than one answer works, no big deal. You just retest another set of numbers. And although that might make you feel like you're going very slowly on the question, it's probably not going to take you more than 30 seconds in 90% of cases because you've already done most of the math, calculations, and strategizing and thinking through the different steps of the problem. You just have to repeat that with slightly different numbers. That usually goes pretty quickly. How useful is this strategy? Well, depending on how comfortable you are doing your algebraic manipulations on questions, it could be extraordinarily useful for you. I think for most of us, there's going to be about 3 to 6 opportunities to use this strategy on the exam. And if you're seeing 5 or 6 opportunities to plug in numbers, that's more probably than the total number of geometry questions that you're even going to see on the test. So it's definitely a strategy that has a lot of application and a lot of relevance to most people's test day experiences. So in my opinion, it's definitely worth practicing. And practicing is the next step if you haven't mastered this strategy already, because so many of us have been conditioned for so long just to default to algebraic solutions that we're often making the test harder than it has to be by avoiding picking numbers, or just not being aware enough or skilled enough to pick numbers, execute the strategy quickly and confidently, and get an answer. I'll give you a tip for practicing this. I think the best thing to do is just go through the official guide and find all the problem-solving questions with variables in the answer choices and perform this technique on every single one of them. What you'll probably realize from doing that is that this technique might not always be the optimal route. Sometimes algebra is much simpler and much easier, and that's particularly true if you're very strong with algebra. But here's the thing. There's 2 benefits to doing the exercise this way. The first is you'll get a lot of repetitions using this technique, even on problems where it's maybe not the best approach, which will challenge your technical abilities and help you hone the technique so that you get better at it. The second advantage to going through all the problems, even though not every problem might be optimally solved with plugging in numbers, is that you'll start to develop a sensibility for when algebra is the best solution for you and when plugging in numbers is the best solution for you. And that type of practice is extraordinarily valuable because it'll allow you to make faster decisions under pressure and more tactical decisions under pressure, because you'll be able to look at a problem and say, oh, on this type of problem, I think algebra is usually the best for me. And here's the reason why. I've solved several problems like this in the official guide, and so I'm prepared for this. Or a question might show up on test day and you think, oh, this one has 3 variables in the answer choice. When I see lots of variables in the answer choices, then plugging in numbers is usually better than algebra for me because maybe I'm a little error prone when I'm doing algebra by hand. Whatever the case may be. You just want that self-awareness, if that makes sense. So if you have questions about this technique, feel free to reach out to me. I'm at the GMATstudy on Instagram, /the GMATstudy on Facebook, Reddit, and YouTube. And feel free to reach out if you do have questions. As always, my greatest hope is that this material will make your studies as easy and as painless as they possibly can be. If you want more tips and strategies for optimizing your performance on the GMAT, just head to my website, thegmatstrategy.com, and check out my free video presentation on how to achieve your goal score in half the normal time and with half the normal effort. In the meantime, this is a weekly show, so please subscribe and stay positive and stay consistent with your studies. I'll talk to you soon.